Now let's find a vector whose magnitude is given. It says that we have to find a vector whose magnitude is 4, right? And it is parallel to this vector. Now, we need to find the actual vector. So let's say that vector A is equal to this parallel vector, right? And let's find the magnitude of A. Obviously, the magnitude of A is basically the square of this term, and this term, the sums of the squares of these terms, whole under root. So you get under root 49, which is equal to 7. So that's the magnitude of the vector that is parallel to the vector we actually have to find. And the magnitude of that vector is 4. That's already given to us. That simplifies this a bit. So the unit vector parallel to A, right? The unit vector parallel to A, so this vector is equal to the actual vector A divided by its magnitude. We know the magnitude is 7 and the actual vector is already given to us in the question. So to find the required vector, you simply have to multiply the magnitude of that vector with the unit vector A, which is this, right? So basically, let's just say that the vector that we had to find was vector B. So B is equal to the magnitude of B into the unit vector A, because but the condition is that A is parallel to B. So basically, the unit vector of A and the unit vector of B are same. Since they're both parallel, the only difference is the magnitude. The magnitude of A is equal to 7 and the magnitude of B is equal to 4. But the magnitude of the unit vector is equal to 1, obviously, because it's a unit vector. And the magnitude of unit vector B is also equal to 1. But here's the thing. These two, all of these have the same direction because they're parallel, right? Same direction. So the only difference between A and B is the magnitude. But since everything about the unit vector is the same, so the unit vector A is equal to the unit vector of B. Which is why when this is basically equal to B into B, the unit vector B, right? So I hope that simplifies it down a bit. And